The diagram above shows a net that folds to make a box. There are two different nets shown below. Each net folds to make a box. The base for each box is labelled. For each box, label the face that will be the lid. So let's look at the example that they've given us. We know that the base is the bottom of the box, and these faces that are next to the base will all fold up, and then when this face here has folded up, the lid will be able to fold over the top, so be above the base. So let's look at this diagram here. We have our base as this face here. So this face will fold up, this face will fold around and so cover this side. This face will fold around and cover this side, and when this face here has folded around, that means this face will be able to fold all the way around and cover this edge of our base. And that means our lid will be here, because when this face folds up, the lid will be able to fold over the top. Now let's look at this diagram. The face here will fold up, the face here will fold round and cover this edge, this face will fold round and cover this edge, and when this face has folded round, this face here will be able to fold all the way around and cover this edge here, which means that the lid will be this face here. 40 children predicted who would win the boys' race at sports day. This pie chart shows their predictions. So the pie chart here shows the predictions for 40 children. 10 children predicted the winner of the race correctly. Who won the race? Explain how you know. So there are 40 children making predictions, so the pie chart is 40 children, but only 10 children got it right. So which of these shows 10 if the whole pie chart is 40? Well, Jack won the race because the pie chart shows 1/4 for Jack, and 1/4 of 40 is 10. And we know that 10 got it right, so 10 children out of 40 must have chosen Jack. And 10 out of 40 is the same as 1/4. And Jack has 1/4 of the pie chart, which we know because we can see a right angle here. And when we have a right angle in a pie chart, that indicates 1/4. Now, what percentage of the children predicted that Stefan would win? So we can see the section of the pie chart for Stefan is here. But to work that out, we need to find the percentages for Amir and for Jack as well. So Amir's percentage will be 50%, because we can see that this covers half of the pie chart, and 1/2 is 50%, because 1/2 is equivalent to 50 hundredths, and a percentage is a fraction with a denominator of 100. Now Jack will be 25%, because that's 1/4, and 1/4 is equivalent to 25 hundredths, so 25%. Now percentages need to add up to 100% if we're finding a total. So we have 50, 25 and 5, so that's 80 altogether. So 80% of the pie chart is not Stefan, so if we subtract 80 from 100, that tells us that 20% of the pie chart is for Stefan, because 50 plus 25 plus 5 plus 20 totals 100%. So 20% predicted that Stefan would win. This graph shows the cost of phone calls in the daytime and in the evening. How much does it cost to make a 9-minute call in the daytime? So we have length of call in minutes on the bottom, and 9 minutes will be right in the middle of 8 minutes and 10 minutes. Now we want to know the cost in the daytime, so we need to look at our line which shows daytime. When it hits the line, what we can do is draw a line to the left and then we can see that the cost of the call is between 40p and 50p, and it's right in the middle, so that means the cost is 45p. Now, how much more does it cost to make a 6-minute call in the daytime than in the evening? So we can find 6 minutes and draw a line up. In the evening, we can see if we draw a line across, the cost is 10p, and in the daytime, if we draw a line across, the cost is 30p. Now the question asks how much more, so how much more is 30p than 10p? To find how much more, we're finding the difference, so we need to subtract, and 30 minus 10 is 20, so it costs 20 pence more. Write the correct sign in each box to make these sentences correct. First, we need to compare 3/10 and 5/10. 3/10 is less than 5/10, so we need a symbol for less than. Now we have 1/3 and 1/6. We need to remember that the larger the denominator, the smaller the fraction, and the smaller the denominator, the larger the fraction will be. Because if the denominator is small, then the whole hasn't been split into as many pieces, so each piece will be larger. And that means 1/3 is larger or greater than 1/6. We can see if we make the denominators the same, that 1/3 is equivalent to 2/6, so 2/6 is larger than 1/6. Now we have 2/4 and 1/2. 2/4 is equal to 1/2 because if we find a fraction equivalent to 1/2 with a denominator of 4, remember we use multiplication to find equivalent fractions, so 1/2 is the same as 2/4, so we need an equal sign. Circle two numbers with a difference of 8. So here we have both negative and positive numbers. So if we start at -5, if we add 5, that will take us to 0. But then we want a difference of 8. So we can add 3 more because 5 plus 3 makes a difference of 8. So 0 plus 3 is 3. And that means that -5 and 3 have a difference of 8. From -5, we need to count on 5 to get to 0, and then count on another 3 to get to 3, and that's counting on 8 altogether. If we started at -4, we could count on 4 to get to 0, and then to make a difference of 8, we need another 4, so we could have -4 and 4 as well. And if we started with -3, we could add 3 to get to 0, but that's adding 3, and we need to add 8, so we can add 5 more, and the difference between -3 and 5 is 8, because to get from -3 to 5, we need to count on 3 and then count on another 5. So we could have -3 and 5 as well. Emma saves £3.50 each week. How much has she saved after 16 weeks? So we need to multiply £3.50 by 16, because that's how much she saves each week, but we need the total for 16 weeks. So if you see the word each in a question and you need to find the total, that's a big clue that you need to multiply. So we can work out £3.50 times 16. Now we could use the column method, so writing the number with the most digits on top, copying down the decimal point into our answer, and then multiplying, and that will give us £56 as our answer. But here, I probably wouldn't use the column method. She saves £3.50 each week. So after 2 weeks, she will have saved £7 because that's £3.50 times 2. And then we need to find the total for 16 weeks. 2 times 8 is 16 and 7 times 8 is 56. So we get the same answer just by counting up, and I find this easier than using the column method, but either method will work. Khalid makes a sequence of 5 numbers. The first number is 2, the last number is 18. His rule is to add the same amount each time. Write in the missing numbers. So to get from 2 to 18, he's made 1, 2, 3, 4 equal jumps. We know that they're equal jumps because his rule is to add the same amount each time. Now the difference between 2 and 18 is 16. So if we divide the difference, divide 16 by 4 because there's 4 jumps, that tells us that with each jump we'll have an increase of 4. To get from 2 to 18, that's an increase of 16 altogether, but because we have 4 jumps, it's an increase of 4 with each jump. So 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, and then to check, 14 plus 4 is 18. PQ is a straight line. Calculate the size of angle X. So we've been reminded here that we have angles on a straight line. So we need to remember that angles on a straight line always add up to 180 degrees. So 47 plus 26 plus whatever X is will have a total of 180. So to find X, we can work out 180 minus 47 minus 26. So because we're subtracting and then subtracting again, sometimes it's easier just to add up the total of what you're subtracting, and 47 plus 26 is 73. So if we work out 180 minus 73, that gives us 107 degrees for angle X, and then we can check 107 plus 47 plus 26 should give us 180. What is the perimeter of a square with an area of 64 centimeters squared? So here we can remember that the perimeter of a shape is the distance around the outside of it. But we don't know what the length of each side of our square is. However, we can work this out because we are given the area of the square. So to find the area of a square, we multiply the length of one side by itself. So something times something is 64, and it's a square, so it has to be the same number. So 8 times 8 is 64, and that means the length of each side of our square is 8 centimeters. Now remember, the perimeter is the distance around the outside, so we have 8 plus 8 plus 8 plus 8, and 4 times 8 is 32. So the perimeter of the square is 32 centimeters. Now give an example of a rectangle with an area of 64 centimeters squared but a different perimeter. So rather than 8 times 8, we can find other factor pairs for the number 64. We could have 64 centimeters and 1 centimeter, so a length of 64 and a width of 1. If we find the perimeter, 64 plus 64 plus 1 plus 1 is 130. So a rectangle with a length of 64 centimeters and a width of 1 centimeter has an area of 64 centimeters squared and a perimeter of 130 centimeters. Or we could have 32 centimetres and 2 centimetres. Then we have a perimeter of 68. So a rectangle with a length of 32 centimetres and a width of 2 centimetres has an area of 64 centimetres squared, because 32 times 2 is 64, and a perimeter of 68 centimetres, because if we add up the total distance around the outside of our shape, that gives us 68 centimetres as the perimeter. There are lots of other possibilities, so we could have 16 centimetres and 4 centimetres. That means a rectangle with a length of 16 centimetres and a width of 4 centimetres has an area of 64 centimetres squared, because 16 times 4 is still 64, and a perimeter of 40 centimetres. Write all the numbers between 50 and 100 that are factors of 180. So remember, a factor is like the opposite of a multiple. This question is asking us, which numbers have 180 in their times tables, but they only want numbers between 50 and 100. So we can find factors by dividing. 180 divided by 1 is 180, so 1 and 180 are factors. If we divide by 2, we get 90, so 2 and 90 make another factor pair for 180, because notice 2 times 90 is 180. If we divide by 3, that gives us 60. If we divide by 4, we might need to use short division for this, but that gives us 4 and 45. If we divide by 5, we get 36, so 5 and 36 are factors as well. Now we could keep going. If we divide by 6, we'll get a whole number as well, and 9, 10, lots of other numbers are also factors of 180. But we don't need to waste time finding all of the factors if we can spot a pattern here. Notice the divisor is increasing and the quotient is decreasing each time. Now we've already gone below 50, so we don't need to do anything else. We just need to find which factors we have here are between 50 and 100. So that's 90 and 60. So 60 and 90 are numbers between 50 and 100, and they're factors of 180, because 180 is in the 60 times table, that's 3 times 60, and in the 90 times table, that's 2 times 90.